Hi, everybody. All right, so we'll record this. Just to give you a heads up, I'm recording this at home, so don't worry if there's a little bit of noise in the background. It's just how weekend work goes. So we're going to go through week 3 work here for ANIM 231, and we're going to take a look at some new challenges that we have for Show Shepherd. One of the things is that we want it to run either standalone or importable. So we want to be able to import it as a module, but we'd also like to run it as a standalone script. So we want to be able to handle both of those conditions. We want it to be cross-platform. We'll get into some of the details there. And we also want to be able to still generate our show shot folders. That's no big deal. But some of the other new functionality we want to do is be able to launch programs within the context, being aware of which show and shot we want to work on. So this is be part 1 of our little exploration of this. And so let's just take a look at a couple things. We're going to look at this whole idea of being able to run as a standalone script versus being importable. So we want one script that'll run both ways. And for run code, we want to be able to handle our arguments. And if it's imported, we want it to behave as an imported module and not do anything extra. And in terms of being cross-platform, we need to be able to use the appropriate slash direction if we're on Windows versus OS X. And we also want to get to a point where we know where the various local applications are, and information about the system that we're running on. So we'll see how much of this we get through in part 1, but this is the start of our work. So let's start right away with this whole idea of running standalone or importable. And for this, I'm just going to use an example. I'm going to create a blank Python script called foo. It's always fun to just experiment with foo and then delete it when you want to. So this is already saved, and I have it saved in a folder called Show Shepherd. It's in my home documents folder. So it's my home directory, documents, Show Shepherd, and then I've got foo.py. So if I fire up a here, and obviously I'm working on Windows instead of PC, so some of the commands are different. So CD still works, so I hit CD, and I'll start typing the word documents and hit tab, and that gets me there. And then I'll type in the word show and hit tab, and that gets me to Show Shepherd. All right, so that puts me in the directory where my Python scripting is. So I can do ls instead of dir to get a list of everything. And there's foo.py, and I've got hello.py, and that's, both of those are blank right now. So going back to terminal, I can run Python if I just type in Python. There's Python. That's nice. I can exit out. So if I want to run foo, just as a quick test, I can just add a line to foo and say print, hello, I am foo, and save that. And then I can go into my terminal, hit my up arrow to get my Python command back, and I'll just type in foo.py. Right, hello, I am foo. So that's working out nicely. So the challenge here is that I'd like to be able to import foo as a library in case I have defined functions in there without automatically running code, right? So just as an example of that, if I go to hello.py, I could say print, all right, and hello, I am hello.py. All right, so we saved hello.py. And just as a test, if we go ahead and hit my left hand and then just type in hello.py, I just typed in, capital HEL and then tab brings me that. It says, hello, I am hello.py. So what's interesting here is if I go ahead and import foo as a module, right? So I go import foo and save that. Remember, import foo has one command, hello, I am foo. So if I run my newly save hello.py, up arrow, run. Now it says, hello, I am foo, hello, I am hello.py. So what we'd like to do is only say, hello, I am foo on demand if we've imported it. And so we'll create a definition. We'll define a function for that, right? So we'll just say define hello, and put parentheses. We don't need any parameters. colon tab, return, and then tab. Here's our print hello, I'm foo. And what we'll do here is say that when foo runs, you want to say, oh, so there we go. So we're just running that defined command right here. Right. So if I hit save and I go back to my terminal and let's see, pi, sure enough, I get hello, I am foo. So what's happening is the function hello in foo is defined, and it is then called by this line right here, line 6, hello, with parentheses, says to do this. Okay. Back here on hello pi, what I'd love to do is say import foo, print hello, I am hello pi, and then right here, run my foo hello, right? So I type in, here's my module foo, and type in my function that I defined, hello, parentheses, right? So save that. Now, ideally, what I'd like to see here is print hello, I am hello pi, and foo hello would then run, which would say hello, I am foo. But if we go here right now and we run Python hello pi, we get hello, I am foo, hello, I am hello pi, and then so this is still happening. And the reason that's happening is that at the moment that we import foo, it defines the function, but then it also actually runs the function. So we want to skip this if we're not actually running foo as a standalone script if we're importing it. Okay, so the trick for that is to take advantage of a reserved variable, a reserved value in Python that's it's actually name, double underscore name and 2 underscores. All right, so there's 2 characters at the end, 2 characters at the beginning, and I can just say print name. Okay, so that's going to be the only thing that I actually run right now in FooPy. It'll define this function no matter what, but it'll only say print and this reserved word underscore underscore name underscore underscore. Right, so I hit save. And so here's what's interesting. If I run hello pi, which again, it's going to import this, so it'll define the function, and then it'll run this line. I'll go ahead and run that, and you'll see name is foo. Oh, that's nice. So it's self-aware now. It knows that it's named foo, really, as a variable. Here's what's pretty cool. If I run foo, exactly the same code, no different, I get a different value for that reserved value name. It's double underscore main double underscore. So this allows us to be able to understand whether at this moment we are running as a script when we say Python FooPy, or if instead we're running as a module, its name is foo, being called by some other script. So we can use this to decide whether or not we're going to run any commands. So let's just take action on that, right? So we'll change this print statement, print command, and we'll say if name equals underscore underscore main underscore underscore colon. Now, quick note about booleans. If I do this statement all by itself, it's actually taking the word main here with the underscores and putting it into that variable. So saying if name equals this is actually invalid. I could save this right now and just show you that that's the case. So we just run foo and we say syntax error right here. So if you ever see this, the reason is that the idea that I want to say if the name happens to be equal to this. So I'm evaluating, does this actually equal this? It's a different symbol. It's not just the equal sign. It's actually 2 equal signs next to each other. So with this, if name equals double equals main, then I'll say print. In fact, then I will actually run hello. And maybe just for that, I will say, by the way, I'm just using tabs as my indents. Print is running as a script. All right, so what'll happen is we'll immediately, anytime you load up foo, whether it's an import or as a script, it'll define the function, and then it'll run this if statement. And the first thing in the if statement is, well, if the current name of what I'm running is main, then go ahead and print this running as a script and also run the hello script. So I'll save that. What'll be cool is that this will be false when we call foo as an import, and therefore this piece won't run. So let's go ahead and look at what happens. If I run foo pi, sure enough, this is running a script. Hello, I am foo. But if I go up arrow enough until I get back to my Python hello pi, and I run that, it's importing foo, and I only get hello, I am hello pi, and then hello, I am foo. So we skipped over this bit of code by including this little if statement. And so now I import foo. Nothing happens by the virtue of importing foo other than defining the functions. And then I go ahead and into my statements. So that's really handy. So we're going to be using that going forward as a way of, we'll build out our shepherd.py in such a way that when we run it, we'll have a little bit of code that's run to see if we're running as the main script, in which case we'll take action on arguments and such. Otherwise, we won't do anything. We'll just simply define all the functions, and that way we could import our new shepherd pie as a module for use inside other programs like Maya, Nuke, and such. Okay, so that's one problem solved. So the next problem is that we want to make sure that we are going to be cross-platform, right? So we ran into some issues in terms of using the / versus the backslash in our applications, and if we run in Maya and we use the wrong direction / then we can't work with files, right? So for example, if I want to check the directory, existing of a directory. I'm in this show shepherd directory and it's in documents, right? So let's say I want to find that. So I'm going to just define a new function in foo and find, let's say, find home, right? And we just parentheses and tab. All right. So let's introduce a few new functions that are available to us in the OS path. So we'll add our import OS here. And find home, we'll use a function. I don't think we've used this one yet. So it's os.path. And what we're going to do is expand user. And what we do is put a tilde character, which is kind of, this squiggly line, I think is what we're looking for. Let's just make sure that works. Tilde. And quote and close that up. All right. So let's just print that. Print the return of this, right? So instead of this is running as a script, instead of hello, and this is only when we run it as foo, we'll just say we're going to run find home. Okay, so we'll save that. Let's just see what we get. I'll up arrow till we get to Python foo and run it. And sure enough, I've got my path to my home directory. So that's kind of cool. So if I wanted to build a folder, but this was, you can see on the Mac, I've got /, right? So if I wanted to say print, I know show shepherd, right, is my directory here. So I can Command C, copy that. And I'll just put a plus and a quote and a / and a show shepherd and a quote and save. And I can put those together and went home. So I saved that and run it. And so we have a nice Macintosh directory path. The only problem with this is that if this was on Windows and I had C : users and my thing and all that, this wouldn't be where I was. In fact, by the way, this is the wrong place because I'm actually inside documents, right? So probably want to do show shepherd documents. All right, save. So we can hit it up. There we go. So that's nice. So, and again, if I cd back, there is documents and cd sh tab show shepherd. Okay. So what I want to do is build this path in a way where I'll get the correct / regardless of which operating system I'm running on. And so the trick for that is a function in OS path called join. Okay, so let's just say this path equals, and we'll still use this right here. This, cut that, That's it. So os.path expand user. All right. So what we're going to do is use os.path join. All right. So let's see. We'll see the end. So we don't forget. And instead of adding this full string, what we'll just do is we want to add some more folder path to this, right? So that'll be my first parameter, os path expand user. That gives me my user path. I'll hit comma and put in quote documents, and then comma, and then quote, and my show shepherd word, and quote. So now what's going to happen, save that. So what's here is that I can give join as many different strings as I want, one after another, as long as I separate them by a comma. And what OS path join will do is automatically replace these commas with whatever the appropriate slash direction that I need, depending on what operating system I'm running on. So if I'm on Windows, I'll get the backslash that I need. Here I am on a Mac, I'll get the forward slash. So just go ahead and make that run. There's Python foo, and sure enough, we get all our path directories. So this will be really useful. Anytime we want to build a path, we want to build it using this os.path.join, and that way we'll always get the appropriate separator. All right, very cool. So that's enough for this video. I'll stop that and send it out to you. And then on our next video, we'll start taking a look about how we can get an understanding of what operating system we're running on, and mainly, really importantly, where are the executable files for the programs we're going to run. All right. See you soon.